Hello everyone, welcome back to CourseSeeded. So we were at this question and then we were going to for the part 2. So basically we are to travel this in all the 4 directions, basically left, up, right and down. So what we'll be doing, we'll be just checking that this path exists or not with our code. So basically total will be 58 as your answer, as the final answer of your treasure hunt. If you are traveling in all the 4 directions, if you are traveling in just 2 directions, which was your right and down, then we have 52 as the answer, which was, I think, correct over here. Yes, so it was correct. So basically we just remove this 2 and 4. Basically 6 we can subtract from this 58. That will give us 0 to 4, 8, 9, 5, 7, 8, 9, which will be your final answer for just right and down. And for this up, left, right, down, we have this 58 as the answer. So basically we can use DFS over here. So basically let's say you have this. At every cell you have 4 choices, up, down, left, right. So basically DFS is actually naturally suited for this if you want to go to multiple choices. And with DFS we'll just use backtracking to make things simple for us. Backtracking, BFS and backtracking. So suppose if we used BFS, breadth first search, so basically we'll travel in all the directions and then coming back is very difficult from there. So instead we just use DFS and we go to a single path and we reach till its end, and then we come back over here and then mark this 2 as unvisited using backtracking, and then we just go to 3, and then if from there if you want to travel to 2, that won't be a problem, and then we can just go to 5 and all. So that's why DFS is very useful over here. So we'll be using DFS. Obviously you can't use DP for the obvious reason, which I've already told you in the lecture, part 1. So we have your all the things that we need. So basically we need a visited array, I think. So that will be a 2D visited array. So this will be 2D visited array, and then you have your graph as a 2D array, and then you just have your last thing, which will be like your DFS function. So let's create the code. So basically our recursive state would look something like this: DFS of r comma, so basically row and column, and then we'll just have current number of treasures. So if the current treasure exceeds the treasure which it was already holding, then we travel this path. Otherwise we don't travel this path at all. And obviously with DFS you'll be able to travel all the paths in the correct sequence. So we are not going to break this DFS at any point, because that's like useless for now. And obviously for which we didn't reach this last for every DFS that we are unable to reach this last place, then we'll just exit it directly from there. So basically if -1 comes, then we just take our exit for that DFS. And for if suppose for every DFS it comes -1 at that point, then we just take exit from the overall graph, which will be, so we don't have to do for this as well. We just will be just doing it for a single DFS, this -1, and then it will take care of everything by itself. That's why we are going to use this graph method. You can try DP method as well. So basically DP is inappropriate for obvious reasons, like it will be wasting much of your time. So you have this graph and you have this thing over here, which is your question. So let's say we are currently at r comma c and we want to go to the next treasure, whichever it is. So you are at currently r comma c and you have this t number of treasures which you have collected. So we'll mark all these cells visited, so from wherever these treasures have been collected. So visited marked, and then we'll just have your final say, which will be your final this final t will be your answer, final answer. So basically this will be your answer. Well, obviously every treasure that sums up will be your answer at last. And backtracking also helps us in like recirculating the treasures. Basically if we added some treasure at first, then with the backtracking we can just go to that path where this treasure was not there, So basically we will just do t minus value or value at that point, basically v of ij, and we'll be going from here to here, which will be your let's say it will be your I minus 1 comma j. So we'll be just doing for that, we'll be just going from here to here, so that won't be a problem at all. So we have all this. So backtracking will help us in two things, which I've already told you now. So let's start with the code. So let's create some pseudo codes over here. So pseudo code. So basically the problem is actually difficult than that previous problem, but since I explained it so well, you might be able to get everything in a one go. Obviously, if you haven't watched the previous DSA lectures, or if you don't know what backtracking, DFS, BFS, and all of these stuffs are, then obviously my explanation doesn't help at all. So let's go with this. Obviously, if I start teaching everything in every lecture, then it will take around 12 hours for each lecture. So if we have your R as n minus 1 and your this C as m minus 1, that means we have reached the end. So what we can do, we can just call this quits. So basically we have one valid path for this. So we can mark one valid path achieved. One valid path achieved, and we can just like add that path in some value if you want, sorry, in some vector if you want, but there's no need to find all the paths with which we can just travel. We just need to find the best path or the maximum treasure path. So let's see if this answer. So final answer, obviously you know what it will be. So final answer would be your max of answer, comma the current treasure, which will be getting it from our DFS. And obviously the transitions, you know what it will be. So basically you'll be taking dr, basically a small change in row. That small change is basically 1 and minus 1. So let's say we have this 1 comma minus 1 comma 0 comma 0, and similarly we'll have to give it according to this dr, these columns. So 0 comma 0 comma this 1 comma minus 1 or minus 1 comma 1, that depends on you. So basically for these you have to give 0 and 0, and for these you have to give rows as 0 and 0. So basically you can even try this 1 0 minus 1, but you'll just have to change it like this 0, and since there is minus 1 over here, then you can have 1 over here. So this order doesn't matter, but the pairs do matter. Or you can just directly do a small change, basically delta. So let's call it d, let's call it just dx, and then you can just do minus 1 comma 0, and then you can have 1 comma 0, and then you can have your 0 comma 1, and then you can also have 1 comma 0, sorry, 0 comma minus 1. So you can take a direct change in x, or you can just take it in row and column. So I'll be doing it according to the row and column. Basically it just doesn't matter what you're using, you just have to find the correct answer. So basically nr, basically the new r would be your r plus this dr. Okay, so if you have solved few lead code questions, then you should know this pattern. So basically it's a very easy pattern to recognize. So you'll be just going with this, and obviously there will be a k. So basically k ranges from 0 to 4, 0 to 3 I would say. Basically indexes are from 0 to 3 for this. So 0 less than equals to k less than equals to less than 3, where k belongs to integers. So this is your set for k, or you can just directly write k belongs to 0 1 2 and 3. So these are the two ways to write k in mathematical way. So after this, what you can do, when can we move, you have to find that. So when can we move? So obviously you can find that just by this. So basically if 0 is less than equals to nr, less than equals to your n minus 1, sorry, not less than equals to, basically less than equals to n minus 1 or less than n. So let's do less than n over here. and you have this 0 less than equals to basically nc less than your m, column is your m, maximum column. And then you have to you have to also check whether it is blocked or not. So let's say if grid has been blocked, let's say nr comma nc, if this is blocked, then we can't move. If this is not blocked, basically not equal to -1, then we can move. So basically this condition have to be there so that we can travel it directly. And obviously there is one more condition, if this has not been visited. So these are few conditions which you have to keep in mind and see. And with this, you can just create a complete if statement for your for loop. So if 0 less than equals to your nr less than n and n. So basically you can't just directly take this in C++. If this would have been Python, then you could have done this. But so let me just tell you how to do this in C++. Basically you already know this, but let me just waste a few more minutes as well. So basically what I mean is, I will just show you why we need this. So basically 0 less than equals to your nr, and then you can just use this nr less than basically n, and then you can use and n again, which is basically 0 less than equals to your nc, and which is your nc less than m, and again you can use your I think grid. So basically we'll be writing it as graph instead of grid. Grid nr then nc is not equals to your -1, and obviously not visited, basically nr comma nc. So I've written this in short form. That's not a problem at all, at least not to me. So we have just given everything what we need. So basically we just need these 4 conditions, and we can just write the same code over here, and we can just copy paste it over here. So obviously for 4 paths, or you can say for 4 of them. But instead of doing for 4 of them, we'll be just directly doing it, because we are doing it with graph, we'll be just directly writing a single statement over here, which will give us all the values. Obviously this condition is very helpful. These conditions are very helpful. So let's begin with the code. So let's say we have this int n comma m, then we have c n, then we have vector of int, then we have vector and vector of int, which would be your graph, or you can take grid as well, but let me take just graph. Let's say this is n comma vector int m. So basically in last lecture I will told you what we are doing over here. Okay, so finally we have our graph, and then we can just take input. Actually I should have just copied it from above instead of wasting all the time. So I actually wasted lots of time over there. Anyways, so we just have this. Basically input won't change, just the output and the method has to change. So then we can just directly declare our DFS over here, or we can just declare it over here. So void DFS, let's say we have this DFS over here, and obviously we'll have your DFS as int r. Basically let's have this graph and these n and m as well, or we can just do this vector and graph, and we don't need anything else. Basically we'll be just taking r comma and c comma, there's one more thing I think we need. Let me just check. Okay, so current treasure. So current, wait, let me just write. Okay, I'll be, instead of writing current treasure, I'll be just writing it as CT. So we have CT over here. So what we can do, if r double equals to basically your graph dot size, and basically this is r double equals to n. We are just writing the same thing, not over here, basically over here. So if r is your this, and your c is equals to So basically we are just writing the DFS part. We'll be introducing an R and NC right below this once we have written everything. So we have this, and let's say if C is double equals to graph 0 dot size. So basically graph 0 dot size just gives you the size of the vector inside your this graph, and this graph dot size gives you the row, and this gives you the column. So you don't have to worry what I'm doing. So obviously if it is equals to that, then we can just have your current path is very good, and then we can just replace our treasure with whatever we need. Let me just let me just check what we have over here. Okay, so if this was great, then we can just have the maximum of whatever we need. That looks very good. Yes, so that is the case. So let's say, okay, so I was writing CT instead of current treasure. So we have the CT. So we have our CT as, if this is greater than to your that, let's say the path. What was the path again? Let's say we have a best one more thing, which is your best, whichever it will be. So we can just have, we'll be just calculating this best over here, and we'll be just directly implementing this inside our code. So let's say if this is your best over here, then what we can do, you can just write, let's say there was some best. Instead of writing best over here, we can just decline it as the global variable. So int best equals to your -1. So we'll have this. Then obviously our code becomes much easier. So basically we'll just have to integrate if we don't write it as the global variable. So let's just write whatever we need. And obviously there will be a current path as well. So let's declare that as global variable as well. So if you want, I can just, instead of declaring everything as global variable, let me just declare it right over here. So obviously I didn't want to include it inside this because it will just create a mess for you to read. So let's say best path, or you can say the current path and the best path both are needed. So okay, so let's just write the best path over here. And obviously we'll have your vector and current path. Okay, so current path won't be good for this, so we can just have this current path over here, vector and current. Okay, so no, we can't do it directly over here. Basically why can't we do it directly over here? Because the path has to be every time changed by that, so there is a possibility that we won't be able to change it again and again. So instead we'll be just directly declaring it over here. So vector and current path. Instead of writing everything as best path and all, let's just remember as BP and this as your CP. So current path, best path, current treasure, and there is one more best number of values for the treasure. And we obviously have if CT greater than best, then we can just do this best equals to your CT, current treasure basically, and you have this best path equals to your current path. Sorry, path. So we have this BP equals to CP and best equals to your current treasure. And obviously we can return this directly below this. So let's write return this. So we are just left with few more things. Let's say obviously the main part is right down over here. So basically if we have this for int k equals to 0, so obviously k, I told you it was 1 0 1 2 3. So integer k equals to 0, k less than your 4, or you can just do k less than equals to 3, then k plus plus. So this will give you like 0 1 2 3, and you can just have your new row and new column as what we need. New row equals to your basically r plus r plus r plus r plus R plus what? So yes, so basically this was R plus DRK, and obviously your column will be NC equals to your C plus DC. Sorry, yes, so DK, sorry, not DK, DC or DCK. So we have this NR and NC equals to this. So let's define this DR and DC as well. So we can define it inside this, but that will just consume our memory every time we create this, call this function. So instead we can just call this outside, or let's say for CP, most of you don't like calling it as the global variable. So let's call this inside only. Let's say in DP, sorry, DR. Let's say the size was 4 equals to your 1 comma minus 1 comma 0 comma 0. Then you obviously know what your DC should look like. So basically DC4 should look like your 0 comma 0 comma 1 comma minus 1. Yes, so this looks good. Basically we have 1 minus 1 and then 1 minus 1 at both the sides, and then we can just add semicolon. So yes, we are just at the final stage now. So let's implement if condition, which we wrote over there. So I don't know where it went. Yes, so we have this. For some reason I just got on this animating using my plotly path. Part. Yes, so we are over here. So if nr equals less than equals to 0. So if nr is less than equals to 0, then we can continue. Or let's, instead of writing everything as continue, we can just have this. If nr is greater than equals to 0, or let's write how we wrote it over here, 0 less than equals to nr. Basically 0 less than equals to your nr, and basically nr less than your n, and then 0 less than equals to your nc, and then nc less than to your less than to your this m. And we have two more things, which is your graph. Basically graph 0, not 0, nr comma nc double equals to -1, not equals to -1, then only we can continue. So basically if it is not equal to -1, and obviously you'll have this not visited array. So obviously we didn't take any visited array as well, so let's take that as the final thing that we need. So we'll be just taking it over here, so comma visited. So instead of writing this, we can just write vector let's say vector int. So basically we'll have not just vector int, instead we'll have your vector parent command. Wait, not parent command. So basically in this we'll have parent command. I'll just tell you why. Basically for the path we'll need your coordinates, which are for 2D DP you'll have 2 numbers. So that's the reason we'll need pair over here. So anyways, for the visited array you can just have your usual, which was your vector and vector bool. So where did our yes, so we are over here. So this is the reason I didn't want to like write it over here, because I'm just getting confused again and again. Basically you have to write this on a single screen, which is like half the size of my total screen. So anyways, we have this visited nr and then nc, and if we have this, then we can just go with the final thing. Basically if you want to choose, then we can just have your visited. So basically obviously we are going to choose if that is all true, otherwise you can just explore it. So basically nr nc visited nr nc equals to true. So obviously for backtracking, we'll be just popping that initial value, and then we can just have it again and again. So don't worry about that. So obviously if we are so obviously if we reach this, then we'll have to like remove this current whatever it is, basically this current path. Where is it? Yes, so current path will just get reset after we do this. But obviously there is no need, because when we are writing the code, we'll just do that directly below this. So there's not actually needed. So that's actually not needed. What we'll be doing it over here. So anyways, we have the CP current path. Basically, we'll be just pushing everything inside that current path. So current path dot push back. So we'll just push. Sorry. So we'll just push your NR and NC. Let's say NR comma NC. Obviously, you know why we are using curly brackets, because if you don't know that much, then I'm sorry, I won't be able to tell that. Basically, it just tells you that you are taking two of these things at a single time using this pushback. So basically, pushback just helps you feed one thing. So you can either feed one data type, which is your vector or set or map or anything. So you can feed one data type with this pushback, but there are tuples and other things with which you can push multiple of them. But that's not what we are going to do over here. So obviously with this, okay, so why did I write it like this? So we have this DFS, which we'll be calling. So basically, let me check what we have. So basically we have graph, and then we have your visited, and then we have a few more things. Okay, so visited RC. Okay, for some reason it just gets directly teleported to the end. So basically we have RC, CT, BP, and CP. So we have RC, CT, BP, and then DP. And then CP, current path. So we have all this. So it looks good to me now. So for the backtracking, you already know what we have to do. Basically, current path dot pop back, just this much. And obviously one more thing, which will be your like visited has to be changed to false. So we are just reversing everything what we did. So is equal to false. I've already told you the explanation. We are just doing the same thing in the code. So it's nothing much like we are doing anything new. So anyways, we have this. And then we can have this vector of bool. And that will be of the same size. And we'll just give it some false values. So let's say we have this vector of bool. And then we have this, instead of graph, we have your visited. And then m comma false. Let's keep them all false at first. Yes, so it looks good. And obviously we are going to add few more vectors. Vector of vector pair of intent, basically pair of int and int. So it will be like what all we need. So we needed okay. So we need BP, CP, and what is this? So a CT over here. Basically the current treasure, we don't need to add that. So we have this parent comment, and then we have your final answer. So finally it's over. So we have all the values as false, and then we have this vector parent comment, which will be your usual stuff, basically CP, and then BP. And both will be of size n, I think. Yes. Just wait. So we are just pushing back, so we won't be doing anything like defining a size for it. And let's see for BP what we are doing. So we are just doing BP equals to CP, so we don't need to define a size for this as well. So we don't need to define size at all. And obviously it looks good to me right now. Obviously I'll be checking the code again because that's what we do. So I think we are done with the question, and let's check what errors we are getting so that we can just solve them. So obviously at first you'll have to like write visited 0, 0 is equal to true for everything. So basically first has to be visited, and cp.pushback, obviously the first one. So dot pushback 0, 0. So 0, 0. So we have everything done. Then we can just pass the DFS, pass everything in the DFS, which will be your, I think, graph. Then instead of writing it again, we can just copy paste it over here. Obviously we have everything similar, every name is same, so we don't need to change anything over here. Visited cpbp, and we don't have the CT over here, so we'll be just passing best instead. Wait, so instead of writing best, so let's take so obviously we have this current treasure, so let's call it best instead of writing anything else. Obviously I don't think I did. Yes, so over here we can just write CT plus your best thing, which will be your like grid, grid of NR plus NC, sorry, NC, NR and NC. Yes, so it looks good now. Let me check if there is any more, there are any more errors in this. So we have this, this, and this. Well, basically we have this DFS R equals to N, C equals to M, CT greater than best. Then we define best equals to CT. Then we have BP equals to CP return. Yes. So everything looks good. We have this condition to return, and then we have this complete logic over here for the void function, and we have this best as -1 over here. Yes, so it looks good. Okay, so let's so best +1 we can do, or we can just directly assign 0 over here for that current treasure, or instead we can just add this, since we are already at 0, so current treasure can be equals to this, let's say graph 0, 0, 0, 0. Yes, so it looks good. So basically we'll have your graph 0, 0 as your treasure over here, the first treasure. Yes, so finally it looks good. So let's first try printing the maximum treasure. So let's give this good title, maximum treasure. Maximum treasure for part 2. Basically for part 2, let's write up, down, left, or you can just write for part 2, and then we can just write U D, sorry, D L, and then we can write right, basically up, down, left, and right. So we have this, and then we can write your final answer, which will be your best, and then we can just end the line. So let's try running this. Then we can add this code, and then one more code. So basically it will be like a dots, sorry, it will be like not G++. So we are basically initiating the command of C++ over here. So not C++, we are just initiating the command in terminal by using this exclamation mark in Google Colab. And then we have G++, this p2 underscore 2 dot cpp, and then we have dash o, and then we can just write p over, sorry, instead of writing p, let's write p22. So we have all this. Okay, so we are getting few errors. Let's say we are getting 3 errors to be exact. N comma vector and m comma false, and then we have one more bracket, so it looks correct to me. Was it right? vector and m comma false and false. Well, anyways, okay, so I wrote grid over there instead of graph. I kept saying that we have to write graph, but I wrote grid myself. Basically, it's an old habit. So we have this graph, and obviously instead of writing nc, or basically this m is also an error. Basically, we haven't defined any m over here. I just noticed that we could have defined this graph dot size as n, and we can just do that. So let's do that only. So basically, comma n equals to sorry, or we can just directly write graph dot size in this. Basically, let me just copy paste. So basically, we have this over here, and then we can just have the same thing with a 0 inside that. Basically, it will just give us the size of what we need. So we have done with so we are done with that. Just left with this 39th line error, which is your false. Okay, so we have to use bool over here, not int. I just got that. Yes. Okay, so we just added that below this. We can just have this out of this. Yes. So finally we are so fine. Okay, so I didn't save this. Now let's try. We are just left with two things, which is your R and C. Okay. Okay, so we have to pass NR and NC, not R and C. So basically, let me just write NR and NC. And then you have your over here, you can't just write R and C. Instead, we have to write. So instead, we can just write your this. Wait. So what we can write? So basically, row and column. So basically, row starts from 0 and column starts from 0. So we have this graph visited 0, 0, 0 and graph 0, 0 and then BPCP visited. Yes, so finally it looks good. I hope there are no errors. Yes, so we got everything correct. Then we can just have your P2 underscore 2 and then we can just use your input over here. I hope we get the answer as 58. Then you can have path as the homework question. Okay, so we are getting -1 as the answer. I think we didn't update anything. So if CT is greater than best, then best equals to your CT. That's perfect. But this treasure is not changing, I think. Okay, so it's changing, but it's not changing according to what we need. Okay. So actually it should have been at least 0, if not anything. So let's check what we are doing wrong. So at first we have, okay, so instead of speaking, I'll be just checking this myself and then afterward telling you what the error was. So let me just debug this by writing few outputs over there. So over here we can just have your cout CT right now. Cout CT, and obviously we can just cout N as well. So let's say you're doing CT, let's do this, and then N is to this, basically a comma over it, basically N. and then comma m asterisk, which will be your m, and then we can always end the line. Wait. Okay, so we have this. Let's save this, and then we have our final go, which will be your. Oh, sorry. So we had this NC and all, NC and R. Basically NR and NC. So we are good with this. We just now need the input, which will be your this. Okay. Let's try running this. So we got few things. So basically we got a number of things, which will be your CT 0 to 1 and 0. Okay, so what are we actually getting? Okay, so we didn't need this actually, but anyways. So we have this CT as 0, 1 and m equals to 0. So at first we went to this 0 and then your nr equals to 1 and then your column equals to your 0. That's what we needed. Then 2, then 2, then 3, and then 4, and then all. And over here we got some CT, which was your current treasure, which was basically not as good as I thought. So at 4,4 we are getting this CT as 39, first CT. So it didn't just update in this for some reason. I'll be just checking that right now. Let's check why this didn't happen. Oh, sorry. So we had to do -1 over here. Basically that size is a complete size. Okay, so finally let's try this again. Once more, we need this. So basically I took one size greater than what we needed. So we got the answer, which is your 58. So yes, we are good to go. Let's just remove this. And then we can just have your final thing, which is your path. So basically defining the path is very easy because you have already visited nodes. So we can just do it according to the visited nodes. So let's just do it fast. I won't be speaking much. I'll be directly writing the code. So let's begin with that. So yes, we got the answer, I think. Finally, we got everything. Just wait. We can just remove this. And then we can just have our input. Then we can just pass this over here. Let's run this. And then press enter. Okay, so we didn't get any path. Let's see why not. Basically, auto r comma c is in the BP, which is your best path. So did we update BP or not? So we updated the BP and then we returned everything. So let's see why this is happening. R and then C. So everything is correct, but for some reason we are not getting anything. Okay. So let me write the current path and then check whether it works or not. So basically for the current path, we are just getting 0 and 0. Basically, I think the backtracking just disturbs everything. But I don't think that would put any difference in our best path. So let's try with the best path again. I don't think there was any glitch. Let's try this once more. Okay, so we are still not getting any answer. So let me just try it once more. Let me just check what I'm doing wrong. So for auto r comma c is to bp, which will be your pair comma pair, pair end comment. Then we have your bp as your this. Okay, let me just try it another way. So let's say we are at some x point and we try to do x dot first and then x dot second. Okay, so we are still not getting any answer. That means our BP is empty, I would say. So let's try to clash that. So BP. Okay, so I finally got it. Basically, what we did over here, let me just write this and visited. This we don't need as the current value. Graph we don't need as the absolute value. I don't know why we got the right answer, but anyways, this was our AND BP, and then we have your AND CP. Yes, so finally our answer will be correct. So yes, you got the answer 0, 0 and all everything. So let's check whether it is correct or not by our this tree which we calculated. So we calculated our tree over here, which is your 0 and then 0, 1, then 1, 1, correct. Then 2, 1, which is also correct. Then 2, 2. Then after that we went to 2, 3 and then 3, 3. Then we went to 3, 2. Then we went to 4, 2. Then we went to 4, 3, 4, 4. Yes, so it's completely correct. So we are finally getting the answer correct. So thank you everyone. Thank you for joining. Let's meet tomorrow, which will be your data science lecture. So don't forget to miss. So don't miss that, because obviously there will be maths. At first we have to cover the complete maths, but yes, the fruit will be very tasty if you complete the maths and the code along with it. So thank you for joining. Let's meet afterwards. Bye.